Alright guys, as you saw on the thumbnail of this video, we're going to be solving this radical equation right here without actually squaring each side of the equation. In fact, we're going to be using the idea of geometry to figure out what the value of x is actually going to be. Precisely the idea of Pythagoras theorem. Without further ado, let's get right into it. Now, if we look at these numbers right here, we can see that they are special numbers. In fact, they are all perfect squares. This means that we can write the problem as square root of 25, which is the same as 5 squared, then minus x squared. Again, we have plus this right here is also the same as square root of 144, which is the same as 12 squared, then minus x squared, and this is equal to 13. Cool. And the next thing we're going to pay attention to is a right angle triangle. Let's say we have this right angle triangle here like this. And of course, the angle here is 90 degrees. Now, the longest side, which is the hypotenuse, let's call it A. Let's call this side B and then this side C. And from Pythagoras theorem, we can actually form a nice equation out of this. The longest side, which is A squared, should be equal to the square of the two sides, that is b squared plus c squared, nicely like that. Now, if we compare the right-hand side right here to the numbers under the square root here, we can clearly see that right from this side, we have difference of two squares, but here we have sum of squares, right? We can actually form difference of two squares by making any of these the subject, right? So I'm going to make this c squared the subject, actually c the subject, so that we have c is equal to square root of this right here, that is a squared minus b squared. And if you relate what we have here to this one here, we can clearly see that a is 5, and don't forget that a is the hypotenuse. Then we have b to be equal to x, right? So we have x right here. So x, nicely like that. So now that we have this idea, I'm going to draw another right angle triangle here, nicely like that. And we have this 90 degrees angle here. Obviously, we know that this is now the hypotenuse, so I'm going to put the 5 right here, and this x is actually b, which is this side. Cool. And to get this side right here, that is going to be the hypotenuse squared minus x squared, or square root, which is this right here. So we are going to have square root of 5 squared minus x squared. So this whole right angle triangle here is for this term. Now let's consider this right here. Now to get this one, of course, we need to draw another right angle triangle, but don't worry, we can continue it from this one. Of course, with this one, we can clearly see that the 12 right here is also the hypotenuse, right? So I'm going to extend this line right here because the hypotenuse is 12. I'll extend it pretty much. Cool. Then we have this nicely like that. And as we know, here is going to be the 12, which is the hypotenuse. And don't forget that the hypotenuse is facing the 90 degrees angle like that. Great. Again, we have x here, and this x is actually the height, which is this x right here. And to get this length, of course, it's going to be 12 squared minus x squared, or square root, right? Which is this right here. So we have square root of 12 squared minus x squared, nicely like that. Now let me call this point A, here B, and then here C. Now let me get rid of this right angle triangle here. Now let's see. The distance from B to C right here is actually the distance from B to this point, then from this point to point C. So clearly we can see that that is going to be this plus that. And from the question, the whole of this is giving us 13, and we are almost there, right? Now this triangle ABC right here is also a right angle triangle. The question is why? Now the cool thing is that if we square this one plus this one squared, we are going to get 13 squared, right? So it makes the whole of this a right angle triangle. And always the longest side is the side facing the 90 degrees angle. And now that we know that the longest side is 13, obviously the 90 degrees angle is going to be here. like that. And this time we are almost done. How can we verify, or how can we come out with the value of x? Let's consider about that. Now, to get the value of x from this right angle triangle, what we have to do is to find the area of the right angle triangle. And we know that area of triangle ABC is actually going to be 1/2 times the base. This time, let's consider the base to be BC, which is 13. So I'm going to put 13 right here. Then the height is going to be this x right here. So this times x. And in the same way, we can consider the length of AB to be the base and then AC to be the height. And if you do that, this is going to be equal to 1/2 times the base. This time it is going to be 5, then times the height, which is now 12. Great. And we can come out with the value of x. This time around, we are going to have, in fact, this 1/2 will cancel this. That is, if we multiply inside of the equation by 2. So we are going to have 13x is equal to 5 times 12, which is 60. Pretty nice. We are looking for x, so we have to divide inside of the equation by 13 so that this and that will go. And finally, we are going to have x is equal to 60 divided by 13. And don't forget your unit. Of course, we are talking about area. So maybe I have to put units squared nicely like that. But don't forget that at the end of the day, we are looking for the value of x that will satisfy this equation right here. Of course, we have x squared, meaning that with this value of x right here, being minus or positive, they will all satisfy this equation right here because we have squared, right? So finally, we will say that the value of x is actually going to be plus or minus 60 divided by 13. And that is pretty much it. So guys, I hope you found the video useful. Don't forget to give me a thumbs up, subscribe to my channel for more, and see you again on the next video. And also don't forget to check out this video or this right here. See you, take care, bye bye.